Concept 2, finding the nth term of a geometric sequence. So we've got our sequence here, and last time we were looking at finding the next term or the next three terms in the sequence. Now we're looking for finding the nth term, some other term maybe out here that we don't have to find every term in order, every term before it in order to find it. Okay, so when we're looking at these, we're still looking at finding the common ratio, right? For this one, it's another basic times 2 for each of these, right? My common ratio is going to be times 2, so my common ratio is 2. All right, so to find this next one, I would just take my 8, multiply it by the common ratio of 2 to get my 16, right? Easy. But if I didn't have 8, if 8 was missing, I still wanted to figure out what this term was, right? I could basically take 4, multiply it by 2, and then multiply that by 2. Okay, 4 times 2 times 2 would give me my 16. I can skip those middle ones. Same thing, if I didn't have 4, I could take my 2 times 2 times 2 times 2 to get my 16. All right, and this leads us to our formula, which is basically we don't need any of these random terms. If we have the starting term, okay, my starting term is 1, and I multiply that by the common ratio, right? Maybe I'll have this, okay, my starting term, A1, multiplied by my ratio, and how many times do I have my ratio? I have 1, 2, 3, 4, when I'm looking for my 1, 2, 3, 4, fifth term. So I have 4 common ratios when I'm looking for my fifth term, so it's going to be my fifth term minus 1. Okay, that leads us to our actual formula here. You can kind of see how it's built. Okay, that has our first term times the common ratio raised to the power of the term we're looking for minus 1. Because if I'm looking for that fifth term, I have 4 common differences between the first one and the fifth one. All right? Okay, so let's see how that works with some of these problems. Let's bring this down with us. Okay, so my initial value, my first term, is 2. My common difference is 4, and I'm looking for the sixth term. So n is equal to 6 here. So I just plug those in. I have 2 times 4 raised to the 6 minus 1, or 2 times 4 to the 5th. Pull out my calculator. 4 raised to the 5th is 1024. And then times 2, 2048. So the sixth term in this sequence, where we start at 2 and we multiply by 4 each time, is going to be 2048. And I can go back and check that just to make sure. 2 times 4 once, times 4 twice, 3, 4, and 5, 2048. Okay? Looks like it works. All right, let's try another one. Let's try one with a fraction. Okay, same formula. All right, now I've got 324 as my starting term. I'm multiplying that by my common ratio of 1/3, and that's raised to the 5 minus 1, okay, or the 4th power. All right, so when we're doing that, remember you don't have to worry about the 1 in the top, okay? Or if this was a 2/3, I could do 2 to the 4th power over 3 to the 4th power, all right, and then multiply that. In this case, we just forget about the 1. So we've got a 3 raised to the 5 minus 1, or 4 power. So we've got 81. So this is going to be 324 times 1 over 81, or 324 divided by 81 is 4. Okay, So the fifth term in this sequence is going to be